Now in section 2.5 we'll talk about polygons and spend most of our time talking about convex polygons, but we'll explain the difference between a convex and a concave polygon. Poly means many, so a polygon is a closed plane figure, so there are endpoints. It's not open-ended. You could draw a circle around these figures. And all of the sides are line segments that intersect at a single point. And most polygons are convex, which means all of the angles are between 0 and 180 degrees. So here's an example of some convex polygons. So you can see all of the sides are segments and they meet at a single point, and all of the interior angles here are between 0 and 180 degrees. That's a convex polygon. Here are two examples of concave polygons. And with a concave polygon, there's going to be at least one angle that is obtuse, greater than 90 degrees. And also, if I were to join any 2 points from the side of a concave polygon, that segment would be outside the polygon. Whereas if I were to draw a point connecting any interior of a convex polygon, that line will always be inside the polygon. And here's an example of some figures that are not polygons at all because the sides are not line segments, or maybe because it's not closed. This is considered open. All of our polygons are going to be closed. They have endpoints. And polygons have names. We have some standard names for polygons. Triangles have 3 sides. Quadrilaterals. Quad means 4, lateral means side. Quadrilaterals have 4 sides. And we have a whole chapter on quadrilaterals. Pentagons have 5 sides. Hexagons have 6. Heptagon, H-E-P-T, that means 7. Heptagon has 7 sides. Octagon, octo means 8. Nonagon means 9, and deca, like a decade, means 10. All right, so when we're talking about these polygons, if I were to draw a Venn diagram of all the polygons, we'll call that P, all the different types of polygons, triangles, quadrilaterals, pentagons, hepagons, all the triangles would be in set T and all the quadrilaterals would be in set Q. That's what this diagram is showing, and there is no overlap. In other words, a figure either has 3 sides, or the figure has 4 sides, or we might have our pentagons here, or a figure has 5 sides, but it can't fall into more than one category. So they are described as disjoint. A polygon would fall into the category of a triangle or a quadrilateral, but it can't be both. All right, so let's talk specifically about our convex polygons of 3 or more sides. One segment, or a segment that a polygon will have, is called a diagonal. And a diagonal is a line segment that joins 2 non-consecutive, that means not in order, vertices. That's considered a diagonal. So here, the line segment that connects A and C, line segment AC, that's a diagonal. Just like the line segment AF is a diagonal. And the more sides a polygon has, the more diagonals the polygon will have. So if we were to look at a triangle, and I wanted to try to draw a diagonal, if I wanted to draw a diagonal from vertex A, and I want to go to a non-consecutive vertice, well, I can't go there because that's consecutive, and I can't go there because that's consecutive, meaning in order. So you know what? A triangle does not have any diagonals. But here's a quadrilateral, and we'll make it a scalene. None of the sides have any of the same shape, same length. All right, so a diagonal, it can't go there because that's consecutive. It can't go there because that's consecutive, but I can go there. That segment AC would be considered a diagonal. Now let's go to this point. I can't go from B to A, that's consecutive. I can't draw a diagonal from B to C, that's consecutive, but I can say that AC is a diagonal and BD is also a diagonal. So you see, quadrilaterals will only have two diagonals. The more sides, the more diagonals a polygon can have. And in fact, as the number of sides increases, it's going to become more difficult to count all the diagonals. You know, if you have a 10-sided object, trying to draw all of those line segments and keeping track of which ones you've already drawn is going to be difficult. But there is a formula to calculate the number of diagonals. The number of diagonals of a polygon will depend on the number of its sides. And it's the number of its sides times 3, the number minus 3 over 2. Let's try this out with a triangle. Well, we know that a triangle has no diagonal, so let's just see if this holds out. 3 sides, 3 minus 3 over 2. So the number of diagonals is going to be 3 times 0 over 2. Well, anything times 0 is 0. So that does hold true.